Alright, viewers, my name is Martin, by the grace of God. Now, I'll be talking about differential calculus, specifically differentiation from first principle. Now, students are having difficulty in differentiating from first principle. I don't see anything in first principle. One of the things you need to know is that every point has coordinates. If you have a point like A, for instance, now take note, we said that our slope or gradient is actually the change in y-axis all over the change, the ratio of, y-axis all over the ratio of x-axis. So if that is the case, we have, from first principle, we need to know our coordinates. Now, you know that this physics, this is how your physics graph looks like. For instance, if you have, let's assume this point is 2, for instance, and then here, let's say, is 10 because we're having 2, 4, 6, and then this point, let's assume this point is 9, and then this point, let's say, is 3. Now, these are points. These points has coordinates. Take note. If this point is A, the coordinates, the values of that point will be x1, will be x2, y2, because you start from here. In physics they say this line is called uniform acceleration. So it must start from here. Then if here, okay, let's make this B, for instance. If this point is A, I will have my coordinate as x1, y1. So if that is the case, then it means that when, take note, this y-axis, this x-axis, plus, here is minus and minus, you should know. Now, if that is the case, this point will have coordinates. When x is 10, y is 9. So you now have x first. X is 10, so you have 10 to 9. So the coordinates here, where x2 is 10, y2 is 9. Then the coordinates at this point A will be x and y. In other words, when x is 2, y is 3. So we can, arrange it to be, since x1 is coming first, then you have 2 into 3. These are the coordinates. But you see, for you to differentiate from first principle, you must understand how this coordinate changes. Also, pertaining to our curve, we said if we carry Q that is at the point and bring it closer to P, the length of H becomes smaller and smaller. So that's why when we are differentiating from first principle, we will say at the end of our calculation, we will say as H tends to 0, then Q will tend to be, not Q will move to B. It will move to reduce the size of H. So let's try this now. How do we now differentiate from first principle? Whatever value you have when you differentiate, you should differentiate this now. For instance, we know this will be 6x. 2 times this 6, then minus 1. Now, this 6x you got is the gradient function or the slope. But you see, when you use first principle, you must arrive at the body. The sequence varies, it changes. So let's see some examples, because I will take time to break it down. Now, let us differentiate this from first principle. Let's take the example. Example 1. Let us differentiate. Let's differentiate y equal to x squared from first principle. Now, how do we do this? This y equal to x squared is a curve. It's a curve, it's a curve. So you must understand the functions of coordinates. Coordinates. So if that is the case, we assume to take our point. We have 2 points, P, Q. So you take note, I said the first point is x1, y1. And the second point is x2, y2. Let's see what this means. Take note. Pertaining to point P coordinates, x remains constant. I repeat. Pertaining to point P coordinates, this x1 remains constant. So instead of putting x1, put x. But what then is y1? x1 is x. What then is y1? Look from here. This is the same as saying y1. Let me open it now. y1 is equal to x squared. So whenever I see y1, put x squared. That is the meaning of this. So in place of y1, you're putting x squared, you have x squared. This coordinate is pertaining to P, point P. Let's now come to Q. Now, what are we going to get pertaining to Q coordinates? Now, we said that the slope, let me just, let me show you something. If you have this, for instance, you have our point, you have, let's say here is P, and here is Q. You have your, gradient function at this point. This line that comes here, this x-axis, this h-axis. As Q is tending towards P, coming to P, h becomes small, becomes, of course, if I bring Q here, I'll have a line that will come this way to reduce the size of h. So h must be becoming smaller, and so it must tend to 0 because this is our 0 region. Take note of that. So if that is the case, pertaining to the second point, x2 becomes, take note, for P it is x, so for Q it will be, take note, it will be the sum of s plus a, because this side is your, you don't have this. So you have it as s plus a, x plus h, being your x axis. So in place of x2, put x plus h. So you have it this way. Then what then is your y2? Your y2 is saying that anywhere you see, take note that your y1 is equal to x squared. So anywhere you see, take note, if y is equal to x squared, anywhere you see x, just put x plus h, because this x connotes, the connote axis. So since it is x squared, there will be x plus h all squared. Because you have your y is still this. So just since x is horizontal axis, anytime I see x, just put x plus h. That's what we are saying, all squared. So we can now, get the value for that. Now we said that PQ, the gradient function becomes changed in y coordinate all over change in x coordinate. Now, what does this change? This change means y2 minus y1 all over what? x2 minus x1. Take note. From here, from these two, this x, let me open your eyes now. This x is x1, this x squared is y1, x plus h is x2, and then x plus h all squared is what? y2. Take note of that. So just put everything here. I don't see anything from first principle. So in that case, we have y2 is what now? X plus h all squared. So you have x plus h all squared minus y1 is what? You look up. It is x squared You just put it here. Now, caution. Assuming this is plus something, you must add a bracket. But the minus sign will help you to cancel at ease. But since there is no plus something, leave it this way. There's no need to put bracket. Putting bracket this way is a sign of stupidity. Leave it this way. X is what? X is x plus h minus what is x1? X1 is x. So from there you have take note. This means you have to expand this twice. So from there you have this into two places. You have x plus h into x plus h. That's the meaning of this square. Minus x squared all over. Now look up. X minus x is 0. So it's gone. So you are left with h alone. So this becomes. So let's expand. X times x you have x squared. X times h you have hx. H times x you have plus hx. H times h you have plus h squared. Minus x squared. I will sound on my food. All over h. Now, if you look very well, you can add this. These are likens. You have the invisible one there. 1xh plus 1xh gives you 2xh. Let me remove this one. Plus h squared minus x squared all over h. So if that is the case, at this point, you can see something is 0 here. X squared minus x squared is 0, so this will cancel this. So now left with 2xh plus h. So you have 2xh plus h squared all over what? H. At this point, you now factorize. This h and h squared, so you factorize. Now take note, it is wrong to do this. This is wrong. You cannot cancel, if h cancels h, there is no h again to cancel this. This is madness. So, how can we now solve this? We have 2xh plus h squared all over h. You factorize. Take out h, you have h into 2x plus h all over h. H times 2x is this. H times h squared. This cannot cancel this conveniently. Let's stop all those premature calculations. So in that case, you have 2x 2x plus h. But we said from the graph, as q tends to p, as q moves, h becomes tends to 0. H becomes smaller. So in that case, you write therefore as q tends to p. In other words, as q moves to p, you have h to tend to 0. What are you doing? Anyway, I see h. Yeah, anyway, I see h, put 0. So therefore, take note, this q here, you see, people are saying dy dx. Because dy dx means change in y all over change in x. Which is change in all over change. So y over x, you see them are saying dy dx. So I can conclude here by saying that therefore dy dx will be equal to the limiting value as h tends to 0 gives you, if you put back h as 0, sometimes you see it this way, or they will bring it down to keep it as h tends to 0 will be equal to, putting h here, you have 2x alone, because 2x plus 0 is 2x. So if you now use your eyes to differentiate this, you must have 2x. Because 2 times x, 2x minus 1 is 1. So there's an invisible one here, which is not useful at this particular point in time. So thank you very much.